Here we go again, more differentiation rules. Woo! So today, we're going to get a little bit beefier. We're going to be digging into the chain rule. So if we look at the polynomial y equals 2x minus 1 cubed. Well, it's a polynomial. We could use the binomial expansion, and we could expand this out, use our power rule, do what we did in the previous section, and we'd be good to go. But we're going to need this skill known as the chain rule to deal with much more complicated functions. So let's see if we can't figure out how the chain rule works by thinking of this function as the composition of two others. So what two functions are being composed to give us our y equals 2x minus 1 cubed? The f of x, the outside function, is x cubed. And the g of x, the inside function, is 2x minus 1. For simplicity's sake, since we called y the f of x, let's call, let's call u g of x. So now our derivative, dy dx, we could think of this as being the derivative of y with respect to u, because that's what's inside of the y. This is really u cubed. And then multiplying that by the derivative of u with respect to x. So this is what the chain rule is. It's taking the outside function and differentiating with respect to the inside, and then differentiating the inside with respect to x. So, okay, great, cool. What does this mean? Great, cool. What does this mean? dy du. Well, y is u cubed, so this would be 3u squared times the derivative of u with respect to x. That's going to be 2. The derivative of u with respect to x, the derivative of 2x minus 1 is just 2. Remember, it's the rate of change there. That's a linear function up here. So this is equal to 6u squared. But remember, u squared was really, what was u? Well, u was 2x minus 1. And there is our derivative with respect to x. I would do this slightly differently. That's the more formal way of thinking through it. But if I had y equals 2x minus 1 to the third, and I wanted y prime, I'm going to use the power rule on the outside. And the inside doesn't change. That's my derivative with respect to the inside, times the derivative of what's inside, times 2, and we get right there. And we'll do some practice with this, don't you worry now. But formally stated, here is our chain rule. If f is differentiable at the point u, then u is the g of x, it's the inside function, and g is differentiable at x, then the composition of f and g is differentiable at x. Furthermore, if we say that y equals f of x and u equals g of x, then dy dx is dy du times du dx, or the derivative of the composition is the derivative of the outside with g inside times the derivative of what's inside. And that's the way that I approached it the second time through. So let's do a couple examples. We're going to differentiate y equals 1 minus 3x to the 7th with respect to x. So the outside function is something to the 7th power. Well, how do we deal with that? We bring the exponent down and decrease the exponent by 1, and we leave the stuff that's in there. Times, since that stuff in there is more complex than just x, since it is another function, we have to differentiate it. Well, what's the derivative of 1 minus 3x? It's negative 3. So our derivative cleaned up is negative 21, 1 minus 3x to the 6th. Example 2. F of x is the square root of 3x squared minus 4. I want the derivative. Well, you know, we can't really do anything with the square root. We haven't, oh my goodness, we can't do that. Well, yeah, we can. Because remember, square roots are just exponents in disguise. There's our f of x. So f prime is going to be the derivative of the outside. Well, the outside is something raised to the 1/2 power. How do we differentiate that? That's a power rule. We take the exponent down and decrease by 1. And we leave the inside part all alone. But then we have to multiply by the derivative of the inside part. Derivative of the inside part, 3x squared minus 4, we have to use the power rule again. The derivative of the minus 4 is 0. The derivative of the 3x squared is 6x. So simply put, f prime of x is equal to 3x times 3x squared minus 4 to the negative 1/2, or we could say that this is equal to 3x over the square root 3x squared minus 4. There's our derivative. Wasn't that fun?